As we begin a unit on polynomials, it's important to first look at what a polynomial actually is. So we're going to define it as an expression, no equal sign, so just an expression made up of variables. So we need some sort of variables in there, mostly the same variable going the whole way through. Coefficients, which are the numbers that are attached to the variables with multiplication, and exponents. And we're going to put a little bit of a restriction here on the exponents. The exponents have to be whole numbers. So numbers like 1, 2, 3, etc. So we have whole numbers. 0 is also included in there. So an example, what a polynomial wouldn't be, is something like this, maybe 4x to the negative 2 power plus 3x to the 1 half. You can see that that's going to not be a polynomial because of two things. One, the exponent here is negative, and two, the exponent here, while being positive, is not a whole number. Specifically, it's not going to be one of those integers. So what a polynomial actually looks like would be something like 4x to the 5th minus 3x to the 3rd plus 6x minus 8. That would be a polynomial. It fits in with the definition that we have up above. Now when we start looking at polynomials, there's going to be some important parts to the polynomial, some parts that are much more important than others. For example, we have the degree, the leading coefficient, and the constant. So first I'm going to start with leading coefficient. Coefficient's number with variable. Leading means the first one. So in our example up here, 4 would be what I'm going to abbreviate as LC, leading coefficient. So 4 is the first coefficient, the one on the largest exponent. And that's going to be important for us a little bit later. Degree is just a really fancy way of saying the largest exponent. So right here I have a degree of 5. And lastly, constant. Constant is the number that's not going to change. It's the number that's independent of the variables. So in this case, negative 8 is my constant. No matter what the value of x is, negative 8 is never going to change. So I have leading coefficient, degree, and constant. They're going to be the most important parts of my polynomial. So when I look at polynomials in what we call factored form, I want to be able to identify those three things without actually having to FOIL it out. So if you look at the first example, if I were to start FOILing this out, I'd get 24x squared plus 6x minus 48x minus 12. And I could go ahead and combine like terms and go from there. But what I want to be able to do is identify these things without actually FOILing. So I want to look at it here and say, okay, how can I tell that the leading coefficient is going to be 24 and that the degree is going to be 2? And that the constant is going to be negative 12. All of those things without actually FOILing. So if I look back up here at my original, the leading coefficient and the degree both come from the first times the first. I get that 24x squared. So if I look at the 3x times the 8x, I get both of those pieces of information. And then the negative 12 in this case just comes from last times last, the negative 6 times the 2. So that's one way that I can tell if I have just two sets of parentheses. So if I come over here to my second example, I can use that similar process in order to get what I want. The leading coefficient is going to be from those two multiplied together. That's going to be negative 6. Eventually just the negative is what's going to matter to me. The degree, I'm going to get a negative 6 x to the 4th, because I have x squared times x squared. And then the constant is going to come from the negative 9 times 2, so that's the negative 18. So essentially, we are just ignoring all of the middle parts of my FOIL. I don't really need them right now, just the beginning and the end. That's all that really matters to me. I can take this process and I can apply it to everything as I go here. Even if it is a trinomial times a trinomial, I can do the same. The leading coefficient and the degree are going to come from there, so I get a 12 with the 3 times the 4, and an x to the 6th, which is an x third times x to the third. The constant is still going to come from there. In this case, it's going to be a positive 10. Don't really need the plus sign. Guess I'm just emphasizing he's positive. So all the middle terms don't matter to me. It's just the beginning and the end right now that I want to see. This gets a little bit more complicated when I get down here and I have 3 binomials times each other. But what I'm going to do is realize that if I were to FOIL this all out, eventually I'd just be taking all 3 of the first terms times each other to get the leading coefficient in the degree. So if I take 2x times 2x times 3x, that gives me 12x to the third. So my leading coefficient is 12, and the degree is 3. Same sort of idea for the constant. I take negative 1 times 3 times 5, and I would get negative 15 for my constant term. Another way to think about the constant is you can just plug in 0 for the x term. When I get to number 5, I have to realize that a third power just means I have another 3x plus 5 and another 3x plus 5. So when I think about the leading coefficient, the degree, and the constant, the leading coefficient is going to be 3 times 3 times 3, which is 27. The degree is going to be x, which is x to the third. And the constant is 5 times 5 times 5, which is 125. Number 6 is very similar to what we'll be looking at when we get a little further into the unit. So you could write it out like I just did, scribble out the squared and write another 4x minus 2. Or you could think of this just being 2 4s. So for the leading coefficient, it's 4 times 4 times a 1 from right there. So I have a leading coefficient of 16. For the x's, I have 2 x's here and 1 x there. So I think of that as x to the third. And for the constant, I have a negative 2 times a negative 2, because there's squared there, there's 2 of them, times a 9. So it would be a positive 36. So there's just an introduction to how I can start to analyze these polynomials before I even have to go through and FOIL them out. I can get a lot of information just by looking at the polynomials. In the next video, we're going to start to look at what the graphs of polynomials look like, and we're going to analyze them using some of the skills that we just developed right here.